Hi there. For this video, we will be discussing how well our model works. We have trained a model on iris dataset that predict the flower category, and we have seen one of the prediction in which it was predicting that the particular data point is a setosa. Setosa. But what is the validation? We don't know that it can be true or it can be false as well. So there should be a way to determine that how well our model works or what is the accuracy of our model, because otherwise it it will be useless to make predictions if we don't know that our model is making good predictions or bad predictions, because sometimes the predictions are not correct. For that, we use a technique of splitting our data. We split our data into two chunks. On one chunk, we do training, and on the other chunk, we test our model. Let's see what this mean in this slide. Okay, let's suppose I have 10 data points. This is 1, this is 2, this is 3, this is 4, and 5, 6, 7, 8, 9, and 10 data points. Okay, before going further, I would like to give you an example. Let's suppose you are teaching algebra to a student. What you will do, you will teach him one question, two question, five question, and after that, to test the knowledge of your student, you will give him another question and you will see how your student will perform in that question. So that will give you how good your student is learning. So here's the same strategy we are going to apply. Here, these are the data points. I have not given the exact values like in numbers, because previously in IRIS dataset, our data points was simple length, simple width, and so on. But for this case, I am not giving any value. It's just for example, it's just for your understanding. These are the data points and these will have labels as well. So let's say its label is this, its label is this. It can be anything. It can be, let's say it is the iris dataset, so labels can be setosa, versicolor, virginica. So here we have 10 data points and respectively 10 labels on which we are going to train our model. But note, we will not train our model on the whole data as we discussed in the previous slide. What we will do, we will divide this data into two chunks. Let's see how it will happen. These are the 10 data points, and let's say I am dividing the data into 7 and 3 ratio. Here we have 7 data points. These are 7. I have separated these data points. Okay. These are now in the training phase. I will train my model on these points. And other three, these three data points, these are for test purpose. I will test my model on these three data points. Now let's see. As we train our model usually normally from in the previous lectures, same way we will train our model on this dataset. After that, now after training, our model is able to make the prediction. What we will do, we will provide this data point to our model. This data point, the pink line. I will show you. I will take this pink line and I will feed this pink line to my model, and I will say, okay, what is the output for this particular data point? And my model will say it is this. It can be anything. Now I will check, because I already know the right output, which is this red. It can be anything. Again, it can be Setosa or versicolor or virginica, and my model can predict anything as well what it have, but it is on which data it is trained on. It may predict Setosa, versicolor, or virginica, but I know that its prediction was Setosa or whatever this red line is. So here I will know whether it is a correct or it is a wrong prediction, because I already know the correct value, but still to validate, I am asking my model to make a prediction. And if it predict correctly, I will say, okay, very good. Now I can use this data for the further use. Otherwise, I will say, no, I have to improve this model. The same example you can take, you are teaching a student algebra, you have taught him 10 to 11 questions. Now it's a test, and you will see how well is your student performing. If he if he passed the test with good marks, you will say, okay, now he is ready for his exam. And here the same strategy, we train our model on this chunk and we test our model on this chunk. Now for this separation to make different chunks, we don't need to worry. It is all done through a module in Python, which is train, test, split, which is discussed in the previous lecture. And what it will do, it will by default separate the data into ratio of 25% and 75%. Like on 75%, we will train our data, and on the other 25%, we will test our model. We will train our model on this 75% ratio, and we will test our model on this 25% ratio, so that we will have the correct accuracy. And to calculate the accuracy, our model will do something else. What it will do, let's say after 25, we were having 25 test points. Okay, we were having 25 test points, out of which our model predicted 20 as correct because we know the actual label. So let's say 20 correct and 5 incorrect, right? So the formula to calculate this accuracy is correct predictions, which are 20 divided by total number of prediction, which is 25, and this division will give you the accuracy. And to make things clear, let's say our model predicted 25 correct labels. There were 25 training and our model predicted all correctly. So what we will do, 25 correct. So 25 are correctly and divided by total are 25. So total are 25. 25 divided by 25 will give me 1. So the probability that our model will give correct predictions is 1, which is like 100%. Our model accuracy is 100%. It is a good model. So that's how we will calculate the accuracy. Now, to let's discuss the same principle on iris dataset. We are having this dataset. What our model will do, it will divide the data into two chunks. Train test module will separate the data randomly. It will take it, let's say it may take these data points as test, and other than these data points as test. It will not follow a pattern. It will take any data randomly. So there are 150 data points. Let's say our model is trained on 140 data points, and these 10 data points was for the test purpose. So I will provide this and I will ask my model, okay, what is this? If my model say it is a Virginica, then I will say, okay, well done, it is the correct label. Same process I will repeat with these 10 test points, and I will have number of correctly predicted labels and incorrectly predicted labels. After that, we can calculate the accuracy with the formula of correctly predicted labels divided by the total test data points.